Hello friends, welcome to VK Lectures. In this lecture, we will be discussing about the concept of averages and the Ising model. The average number, or this is also called average occupancy number. Average occupancy number. Then so let the total energy E is equal to n times epsilon. Okay, so the average energy E is given by U, that's equal to average of n and this times epsilon. So average n is equal to the expectation value of E, or the average value of E by epsilon, or U by epsilon. Now what is U? U equal to minus dou by dou beta log Z. Now earlier we have learnt for a linear harmonic oscillator, the energy E is equal to n plus half h cross omega. Okay, and corresponding Z is equal to e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega by 2. So now from here you can find the U, which is equal to minus dou by dou beta log Z. So you can substitute the value of Z here, and we have already found that U is equal to h cross omega by 2 plus h cross omega into e to the power minus beta h cross omega divided by 1 minus e to the power minus beta h cross omega. So here we have seen E is equal to n plus half h cross omega and the average value of E. So here we have two equations, 1 and 2. So from these average value from let's write here, from 1 expectation value of E is equal to average value of n times h cross omega plus half h cross omega. So this is 1a. So compare 1a and 2, that means this particular equation and this one, you will get half h cross omega and half h cross omega here, and here h cross omega and h cross omega is there. The average value of n is equal to e to the power minus beta h cross omega divided by 1 minus e to the power minus beta h cross omega. So this is how we can find the average value of n. Average length. Average length, here we are assuming there are so many links which are either vertical or horizontal, and so these are different kinds of links. So all these are links which are either horizontal or vertical. Horizontal links like this will not contribute to the length, it does not get extended. Only the vertical length L, 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 L. So all this length corresponds to the vertical distance. So 1L, 2L, 3L, 4L, 5L, 6L. So the total distance is 6 times the L. So the link which are in horizontal position do not, like this, do not contribute to the total length, while links which are vertical, they contribute to the height of the, or the length, total length. Okay, now this link can be vertical, or this can be horizontal. While the vertical link corresponds to length L, and the horizontal length, this one corresponds to 0. Okay, so in general we can write the work done is equal to FL. FL. Now assuming that the total energy is work done is negative, work is done by the system, and you can write W equal to minus FL, and that is the energy, because work done is nothing but the energy. So according to that we can write the partition function Z, which is given by sum over S e to the power minus beta Es. You can write the Z is equal to, there are only two energies. One energy is equal to the vertical energy, which is equal to minus FL, and we have another energy horizontal, which is equal to 0. So only these two energies are present, either minus FL or 0. So Z is equal to, first we will start with 0. So 0 is e to the power 0 is 1 plus e to the power minus beta into ES. ES is minus FL minus FL. So together we have 1 plus e to the power minus of minus plus, so beta FL. So this is the partition function Z. Now we have the average energy. Average energy, which is given by the expectation E is equal to U equal to minus dou by dou beta log Z. So minus dou by dou beta log of 1 plus e to the power beta FL. So we have minus in the denominator 1 plus e to the power beta times FL into e to the power beta FL into FL. So that's equal to minus FL e to the power minus beta, plus beta FL divided by 1 plus e to the power beta FL. So we have seen that energy E is equal to minus FL. Now the average energy E is equal to minus F, because the force is constant, into average of the length L. Now from this you can write average of the length L is equal to the average E by the force. We can put a minus sign, that is equal to minus U by F. Now what is U? U we have already found, that's equal to FL e to the power plus beta FL divided by 1 plus e to the power beta times FL into 1 by F. So FF gets cancelled. So L is equal to, which implies L is equal to L times e to the power plus beta FL divided by 1 plus e to the power beta FL. Now here the average energy, if there are n number of links, if n links are present, then we have to multiply this term with n. So new concept, that is Ising model. Here is a collection of Ising spin. So here we have collection of Ising spin. Now what is this Ising spin? This can take the values plus 1, which corresponds to upstate, or negative 1, which corresponds to downstate. So this Ising spin is a collection of spin which has plus 1 and minus 1 values. Now in Ising spin there are two types of the interaction. There are two types of interaction that are, one is mutual interaction, and the interaction with the magnetic field. So in mutual interaction, the energy E is given by minus J into sum over Ij. So this I and J are the ith and jth Ising spins. Si, Sj, these are the spins of I and jth particle. And now what is J here? J is the strength of ferromagnetism. And interaction with the magnetic field, E is given by minus H into sum over I Si. That's also H is equal to mu times B, mu B. Now the total energy E, this is for a mutual, and this is for a magnet with the magnetic field. So E is equal to E mutual plus E with the magnetic field B, that's given by minus J sum over I comma J Si Sj minus H into sum over Si. Now with the different spins, we need the basis of the uh, uh, basis for each system. So for spin 1, the basis is 2, and spin 2, the basis is 4. That is, this is not spin 1 and 2, this is spin 1 particle. Okay, this is just Ising spin 1 and Ising spin 2. Okay, for first one, there is only possibility up or down. When there are two spins, there are cases like both the particle can be up state, or up and down state, or down and up state, or both can be down state. So these are the different possibilities for two Ising spin particles. Okay, now corresponding to each state, we have let it be E1, E2, E3 and E4. Then Z, the partition function Z, is given by sum over S e to the power minus beta Es. So corresponding to 3 spin particles, there is 2 to the power 3, which is equal to 8. The number of elements are 8, so we start with up, that's 1, then up, down and down. So for 3 spin particle, there are 2 to the power 3, which is 8 number of elements, starting with all the up states, up and up. Now we will start with the 1 down, up and down, then up, down and up, down, up. Now we have 1 up and other 2 downs, then down, up, down, up, and all the 3 downs. Okay. So here all these different energy states corresponds to different energy, starting with E1, E2, etc. up to the last one, En. So here also corresponding Z will be equal to sum over S e to the power minus beta Es. Now for a single particle system, we have only either up state or down state. Up state represent the +1, the down state represent the -1. This is S value for each. Now the total energy E is given by minus J. This is the mutual interaction term. So minus J sum over Ij Si Sj minus H into sum of Si over I. Now this is the interaction with the magnetic field B. This is the mutual interaction. Now since there is only single particle, there is no mutual interaction, so only second term will remain. So energy is equal to minus h times sum over Si. Now what is the value of h? H is equal to mu times b. Now considering this spin, which is plus 1 or minus 1, so S will be equal to my here minus h, and here it is plus h. The total energy here we are talking about the total, we will write like this. When we are considering S is equal to plus 1, the total energy E is equal to, so S is equal to plus 1, so minus h into plus 1, because there is only a single particle Si, so minus h into plus 1, that is minus h, and for minus 1, S1 equal to minus 1, we have minus h into minus 1, that is plus h. So this is energy for these two quantities. Now once we get that energy, the partition function z is equal to sum over s e to the power minus beta es. So that's equal to, first let us start with the minus h, so e to the power minus beta into minus h plus e to the power minus beta into plus h. Now what is this h? H we already know, that is equal to minus mu b, so we can write e to the power minus beta mu b plus e to the power minus beta mu b. So this is the partition function z. Now we have seen e to the power x plus e to the power minus x equal to 2 cos hyperbolic x. So this is z can be written as 2 cos hyperbolic, instead of x you have beta times mu b. So z is equal to 2 cos hyperbolic beta mu b. That is for Ising system. For a two particle system, we have two spin particle system. The number of microstates equal to 2 to the power 2, which is equal to 4, which is as one is up and down, so this is plus 1, this is minus 1. Then okay, let's write both up here, up and up, then up and down, down and up, and both down. So the value of S is here plus 1, this is again plus 1, minus 1, minus 1, this is minus 1, plus 1, minus 1. Now the energy E is equal to sum over minus j into sum over ij Si Sj times minus h into sum over Si. Now here we let us write down the E, so minus j into SISJ. What is SISJ? This is plus 1 plus 1, so that is plus 1 into plus 1, that is plus 1, then minus h into, this is minus h, sum over Si, so this is plus 1 plus 1, that is 2. Okay, Now again minus j into, this is SISJ, plus 1 into minus 1, that is minus 1, minus h into, this is 0 because sum of this is plus 1, this is minus 1. So again this is minus j into product is minus 1, minus h into, again sum is 0. This is minus j into minus 1 into minus 1, that is plus 1, minus h into 0. So that is minus 1 in plus minus 1, that is minus 2. So this equal to minus j minus 2h, that's equal to plus j. This is equal to again plus j. This is equal to minus j plus 2h. So here what we need to understand is these two are of degenerate state, these two, and the other one is non-degenerate. Now let us write down the partition function z equal to e to the power minus beta es. Es is minus j minus 2h, minus j minus 2h plus e to the power minus beta into, now here we can write 2 times because it is j, so 2 times minus j plus e to the power minus beta into minus j plus 2h. So this is a partition function for two spin particle isospin system, and as a practice you can find the partition function for three particle isospin system. Here is a three particle system consisting of three isospin particle. So these particles are arranged in linearly. So this is S1, this is S2 and S3. So since they are arranged linearly, there is interaction between S1, S2 as well as S2, S3. No interaction between S1 and S3 because they are separated. Okay, there is no interaction. So here these S1, S2 and S3 are different arrangement is given. So it is 2 to the power 3, basis to the power 3, that is 8 arrangements are there. So the particles are arranged from in the order. This one indicates the upper arrow indicates the up state, the down one indicates the lower state. This is plus 1, that is the spin. This is minus 1 for down state. So the interaction term is minus j into S1, S2 plus S2, S3. We remember there is no S1 and S3 interaction because they are not placed they are placed linearly. Okay, now minus j into S1 and S2, that is plus 1 multiplied by, you get 1 plus 1, so that is equal to minus 2j. Again here this is plus 1, this is minus 1, so it becomes 0, right? So there is no j term, so this is a 0. Again this is minus 1, this is again minus 1, so minus j into minus 2, that is equal to plus 2j. Again this is minus 1 into plus 1 minus, this is plus 1 into plus 1, that is plus, so this becomes uh, 0 again. So here we have plus 1 and minus 1, this is minus 1 together, this is again minus 1, so that is minus j into minus 2 becomes 2j. Here we have minus 1 again, it is minus j into minus 2, that's equal to again 2j. Here it is minus into minus plus, this is again 0 here, then this is plus 1, this is again plus 1, so minus j into 2, that is equal to minus 2j. Here we have made a mistake here, that is plus into minus minus, minus into minus plus, so this becomes 0 and this is again 0. So what we have is continuing with this interaction with the magnetic field, minus h into s1 plus s2 plus s3, so plus 1 and plus 1, so that is minus h into 3. Here we have minus h into 1, yeah, so 1 plus 1 and minus 1 get cancelled, so minus h into again 1, minus h into again 1, minus h into, here we have minus 1, again here minus h into minus 1, minus h into minus 1, minus h into 3, minus 3, so that's equal to minus 3h, minus h, minus h, minus h, 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 and 3h. So we are ready with the terms. So here we have first term will be equal to minus 2j minus 3h. Here it will be 0 minus, so minus of minus plus h. Here also 2j, 2j minus of sorry, this is my plus, so minus 2j minus 3h, 0, okay, this is minus only, so 2j minus h. So here we will have 0 minus h, this is h with yeah 0, this is again 2j plus h, this is 0 plus h, this is minus 2j plus 3h. So these are the energies. So z is the partition function equal to sum over s e to the power minus beta es. So the first term I will write it for you, the next term you can write. So e to the power minus beta into es is 2j minus 2j minus 3h. So it's the first term. Let us write the second term also. E to the power minus beta into minus h. You can continue this. Here, three isospin particles are arranged as shown. Find the partition function. Now, let us find the energy. E is equal to minus J into sum over Ij Sij minus H into sum over Si. For a three particle system, this H minus H, that interaction term remains same, but here the arrangement is in as shown in the triangle. So S1 will interact with S2 as well as S1 will interact with S3. Similarly, S2 will interact with S3 also. So there is all mutual interactions are possible. So E will be equal to minus J sum over, that is S1 S2 plus S2 S3 plus S1 S3. So this term is added for three particle system, and the interaction term minus H into sum over this remains same, S1 S2 plus S3. This you can continue and find the partition function.